Good morning, students. Today let us see RAID. RAID is redundant arrays of independent disks. RAID provides disk organization techniques that manage a large number of disks, providing a view of a single disk which aims high reliability, high capacity, and high speed. Improvement of reliability via redundancy. If only one copy of the data is stored, then each disk failure will result in loss of significant amount of data. Such a high rate of data loss is unacceptable. The solution to the problem of reliability is to introduce redundancy. This technique is called mirroring or sometimes shadowing. Improvement in performance via parallelism. So consider the benefit of parallel access to multiple disks. That is, simultaneously we can read from n number of disks. Data stripping. With multiple disks, the transfer rate can be improved as we across the multiple disks. Data stripping provides high transfer rates but does not improve reliability. There are two types of data stripping: bit level stripping and block level stripping. Bit level stripping consists of splitting the bits of each byte across multiple disks. Block level stripping consists of splitting the blocks of data across multiple disks. It is assumed that the block numbers start from 0. Data mirroring. Disk mirroring is creating a copy of the entire disk into another disk. It provides high reliability but is expensive because we need multiple disks. First, let us go to RAID level 0, which is non-redundant. So, we will be storing the blocks in alternate disk. In second RAID level, we go for block stripping, that is mirror disk. So here we will be having additional copy. So it increases the reliability. In RAID level 2, we are using error correcting code. This is to ensure security. So which is rarely used in practice, stripes data at the bit rather than block level, uses a Hamming code for error correction. The disk labeled P store the error correction bits. If one of the disks fails, the remaining bits of bytes and the associated error correction bits can be read from other disk and can be used to reconstruct the damaged data. Next is bit interleaved parity. RAID 3 consists of bit level stripping with a dedicated parity disk. RAID level 3 is as good as level 2 but is expensive in the number of extra disks. It has only a one disk overhead, so level 2 is not used in practice. RAID level 4 is block interleaved parity. RAID 4 consists of block level stripping with a dedicated parity disk. RAID 4 provides good performance of random reads while the performance of random writes is slow due to need to write all parity data to a single disk. To find the value of a damaged block, compute XOR of bits from corresponding blocks including parity block from other disks. Block interleaved distributed parity. RAID 5 writes whole data blocks onto different disks, but the parity bits generated for data block stripe are distributed among all the data disks rather than storing them on a different dedicated disk. So you can understand the concept from the block diagram. RAID level 6 is P plus Q redundancy. RAID 6 extends RAID 5 by adding another parity block. Thus, it uses block level stripping with two parity blocks distributed across all member disks. RAID 6 allows to execute read and write requests in the presence of two concurrent disk failure. The various hardware issues are software RAID and hardware RAID. Another issue in the choice of RAID implementation is at the level of hardware. RAID can be implemented with no change at the hardware level using only software modification. Such RAID implementations are called software RAID. Systems with special purpose hardware to support RAID are called hardware RAID systems. Some hardware RAID implementations permit hot swapping, that is, faulty disks can be removed and replaced by new ones without turning power off. Hot swapping reduces the mean time to repair since replacement of a disk does not have to wait until a time when the system can be shut down. Thank you, students.